Hello students, so in this lecture we are going to see one topic in digital image processing, that is geometrical spatial transformation, that is also called rubber sheet transformation. That is, let us say if you have a rubber sheet like this, and let us say we want to scale it. Okay. We want to apply force this side, and this may become more lengthier. Or sometimes, so applying force in one direction, you may say this is a kind of uh, force you applied, that is also called an operator, scaling operator. Sometimes you may want to do like rotating, applying some force, and now this will be rotated like this. Or if you apply force in such way that it should shear transform, means uh, this will become like this. Okay. Same way in image also, sometimes we want to scale it, that is also called resizing. Sometimes we want to simply translate it, just shift from one place to other place. Sometimes we want to rotate the image, or shear, kind of like scaling as well as rotation kind of thing also we want to apply. So let us have an image fxy, and we want to apply a transform. We apply an operator which the image will be resulted in another image gxy after application of the transform. Mathematically, the same can be written as gxy is equal to the transform multiplied by the image, or apply the transform at the image. Okay. Now we are talking about xy, that is the coordinate of a particular pixel. So this coordinate x comma y, here you make it u comma v. After translation, after applying the transform, the coordinate is transformed or shifted to another coordinate, that is u comma v. Okay. So any particular coordinate can be represented as x comma y, or let us say u comma v, and we shall use one third parameter also as 1, that is mainly used for translation, like uh, putting a shift in a generic equation of any curve. We are putting a constant term like y is equal to mx plus c. So c is the bias or initial bias in the equation. Here also we shall use a third coordinate as 1, which we shall use if we want to add a bias, that is called mainly used for translation, is equal to the original coordinate is x, y, and here also we shall use the third coordinate. And now the operator t we shall use as an matrix, mainly 3 by 3 matrix we shall use. Okay, let us say T11, T12, T13, T21, T22, T23, and 001. So here our transform operator is a matrix of size 3 by 3. Okay. Now let us say we have an image that is simply a line. Okay, this is our image, simply having a line. This is x coordinate, y coordinate. This end is 1 comma 2. This end is say 2 comma 3. Now we want to scale it. So we want to apply a transform t, and now new coordinate will be generated uv. So we want to scale it in x direction 2 times and y direction 3 times. Means we want to make u is equal to 3x and v is equal u is equal to 2x, v is equal to 3y. So in x coordinate you multiply by 2, so this will become 2. Y coordinate you multiply by 3, so 2 3 is 6. So this, okay, so this became 2 comma 6 and this will become 4 comma 9. So once we scale in x direction by 3 times, 2 times, and y direction 3 times, so this will become like this. Now for this operation, what should be our transform? So our transform would be, so in x coordinate we want to scale by 2, so 2 0 0. In y direction we want to scale by 3, and third coordinate will be as it is, third column. Now we have image, or let us say only two coordinates we have, 1 comma 2 and 2 comma 3. So third column we shall add simply as 1 1. Okay. So after doing that, let us see what we are getting as UV. So multiply first row, first column, second row, second column. Okay, first row, second column, first row, third column, as we do in the matrix multiplication. So 2, this will become 2. Here it will become 6. Now it is 1. Second row will become 4 and 9 and 1. If you simply ignore third column, so we got 2 points, 2 comma 6, 4 comma 9. What we got here? 2 comma 6, 4 comma 9. So this matrix is our operator, scaling operator. So in scaling operator, the generic values look like this: some cx 0 0 0, cy 0, 0 0 1. So multiplying some constant as cx in x coordinate and multiplying some value in y coordinate. So having this kind of operator, if you multiply with every coordinate point, like we have two coordinate point, 1 comma 2, 2 comma 3. After multiplying you got 2 comma 6, 4 comma 9. So just for an example, we have taken only two pixel values. Okay, pixel 1, pixel coordinate of pixel 1 2, and coordinate of pixel 1 2 after transformation, after applying this particular operator. Similarly, if you want to uh, translate it, means simply want to shift this line to some distance in x direction, some distance in y direction. So length of the line and angle of line will be same, only the coordinate will change. So how to do that? So this is our scaling. Now next is Translate. In translating our operator T, we shall have like this. So first you take identity matrix like this, and here, okay, because once you multiply here, first row, first column, so third column value is the constant term, and here last row value is the constant term. So in order to add the translation, only shifting the third row value of the operator, we shall have some value. So let us say here you have 2, and here also you have 2. Means we want to shift in along x 2 unit, along y 2 unit. Now if you multiply our image with this, so our image is 1 comma 2, 2 comma 3, only 2 pixels, and third column you put 1 1. Now if you multiply, so you will get 1 plus 2, uh, 2 plus 2, and third one as only 1. Second, 2 plus 2, 3 plus 2, 1. So now see, x coordinate also you added 2, y coordinate also you added 2. So this became 3, 4, 4, 5. So simply this whole line shifted to other location with length and angle same. Length of the line and angle will be same, only shifting by 2 unit x direction and 2 unit y direction. Only shifting. Okay, that is called translation. Now if you add this operator plus this operator, these both, then it will become scaling as well as translation. Means along with scaling operator, if you put some value in third row in this two zeros, if you put some values, then it will do scaling by cx cy, and it will do scaling by s1 s2 by this value, translation by this value. So the diagonal element, or you can say that uh, if you have 3 by 3 matrix, this operator T, then the first 2 by 2 is used for scaling, and third row these two value for shifting, like translation. Okay, and the third column value only maintains the like constant term. Now let us move to the another operator. So we discussed scaling and translation. Now let us move to rotation. In rotation, again, let us say we have x, y. Let us say we have only 2 pixel, 1 comma 2 and 2 comma 3. This we want to rotate by 90 degree. So by default rotation will be done along the origin. So there will be one 90-degree angle, and this point will shift here, and this point will shift here. So a line perpendicular to this line, what will be if it is 1 2, this will be -1 and 2, -1 and 2, and this one will be what? How much it will be rotated? -3 and 2. So what actually we are doing, what actually we shall do, for this we shall make the operator here t. T will be cos theta minus sin theta, here sin theta and cos theta, and remaining operators you make 0 0, because we are not translating, so not translating, so this will be 0, this will be 1. So any coordinate x y, 1, x by multiplying by cos theta and y by minus sin theta, x y in one coordinate. Similarly, sin theta and cos theta in other coordinate. So let us try to do for this example. Here we have 2 comma 3, sorry, 1 comma 2, pixel 1. Other pixel is 2 comma 3. Third coordinate you put 0 0 1 0. Here it is put 1 1 1 1. That's it. So 1 2 1 2 3 1. And cos 90, that is 0, sin 91, so -1, sin 91, cos 90 0, remaining all are 0 0, here it is 1. Now if you multiply first row with first column, you will get -2, first row, first second column 1, then 0. The second row, first column -3, then 2, okay, then 0, uh, 1. So UV. So UV shifted to here. So it is minus 2 comma 1, and this point became -3 comma 2. Okay, after rotation. Okay, means here u will become x cos theta minus y sin theta, and v will become x cos theta plus y sin theta. So here we have to see, first you have to find out what is theta here. I mean here theta is 90 degree. Okay, so multiply that angle to x, minus y into sine theta, then you will get the rotated pixel coordinate u. Similarly, x cos theta plus y sin theta, you will get the rotated pixel coordinate v. So in image also, every pixel given the pixel coordinate and angle, to what angle we want to rotate, using this operation rotation will be performed. So in every case the operator T is 3 by 3 matrix with, okay, varying the value of the operator T. The next operation is called shear operation. The shear operation is, let us say you have a piece of rubber and we want to just you know rotate like vertically like this. So after rotating this, this thickness will reduce because some part went inside, or sometimes we want to rotate around this horizontal coordinate also. Okay, so in that case the length will be same but the height will reduce. I mean, if you have an image this like this, let us say this is our image, and this object we want to shear out. So in the same image, this object will become like this, okay, by rotating around horizontal axis. That is called shearing. So for this purpose, what should be the value of the operator T? So T will be, okay, first you write the identity matrix 0, 1, 0, 0, 0, 1. So if we want to shear along x-axis, so this value we shall change. Okay. If you change this value, then it will be rotated vertically. So I'll write RV. RV means vertically rotation. Similarly, if you change this value RH, then it will rotate horizontally. So for shearing vertically, the second row first column value you have to give, and to shear horizontally, the first row second column value you have to change. So by multiplying the original coordinate, multiplying this operator, you will get the transformed operator UV1. So now you can see, we have seen here that if you want to scale, then diagonal value, this two diagonal value you change. Okay. If you want to scale, then third row these two value you can change. So these two for, okay, translation. These two are for scaling. Here this and this for shear. Okay. And shear and scaling both together, if you put all these four for rotation. Okay, so by multiplying this operator to every pixel coordinate, the different kind of transformation you will get, that is called spatial transformation. Okay. So please have a note of this. In the next session, we shall see some more example. Okay. We shall give some exercise also in the lab to apply this transformation on the image and look at how does it look like. And also we shall see after transforming the pixel, sometimes extra pixels will be created, right? For example, if you scale, here you have let us say 4 columns and 2 rows, but here you may get 1 2 3 4 5 6 7 8. Okay, it became twice, number of columns increased. So how to fill the pixel value? So this 4 pixel values already we have, but here 4 new pixel values are created. So how to fill, how to map the intensity value? Okay, so what we shall do, like first will be here. Okay, no, if u is equal to 2x. Okay, so first pixel value will go to second, second pixel will go to fourth, third pixel value will go to sixth, and fourth pixel value go to eighth, because u is equal to 2x. But the intermediate pixels remain empty. So the intermediate pixel we shall fill by nearest pixel value. Like first we shall fill same value as second, third we shall fill as same value as third, fourth, and fifth we shall fill same value as sixth, seventh we shall fill same value as eighth, or sometime average of the neighbor. In order to fill up the seventh pixel, we shall take average of sixth and eighth and fill it. That also we can do. So additionally created pixel coordinate, how to fill with the pixel value. So in that case, we shall uh, take this pixel coordinate and find out the pixel value to the nearest pixel coordinate. So if it is third, so who is nearest of third? Nearest of third may be either second pixel or fourth pixel. Okay. So this third pixel value we shall fill by either second pixel value or fourth pixel value, or the average of both. Okay. So whenever additional pixel coordinates are created, so pixel value will be filled by the nearest pixel value in the original image. Okay. So in the next session we shall see some example, and that in fact I'll put as exercise in the coding lab. Okay, thank you.